हो गया.
Hello, this is Mohit Rastogi and I'm a chemical engineer. I will be taking up the topic of permutation combination for today's class. I have an experience of 26 years and I have taught in various institutes like Akash Institute, Narayana Institute, Catalyzer and Career Point. So today we are going to discuss about permutation combinations. Now today, first of all, we'll discuss the fundamental theorem of permutation combination. The fundamental theorem of permutation combination is itself very fundamental. I mean, it is fundamental to the concepts of permutations and combinations. Okay? Fundamental theorem. Now, fundamental theorem are two in total. That is one fundamental theorem of multiplication and the second one is fundamental theorem of addition. The first one, which is fundamental theorem of multiplication, this I'll be taking up multiplication. Okay? So here an important concept is there is a very important phrase which will come in this and that is very important to emphasize upon. That is, if an event can happen in m ways, and now there is a very important phrase which will come across that with each one of its way, another event can happen in n ways, then now here is the theorem. Then together or simultaneously or one after the other in succession can happen in m into n ways. Actually, this is basically unity method. So, what do we say? That we consider an example. Let's say from place A, you want to go to place B, for which there are 3 routes. And from place B to place C, there are 4 routes. Okay? So, there are 4 routes. So if you want to go from A to B, there are 3 routes, and from B to C, there are 4 routes. Now the question is, in how many ways one can travel? In how many ways? I mean different ways. One can go from A to C. Okay. Now, in how many ways one can go from A to C? We realize that if he takes up the way from this first way, if he takes up, then he has 4 options. If he goes with the second way from A to B, then he has again 4 options. If he goes from way 3, he has again 4 options. That means with one way from A to B, we have 4 options. Okay? So for 3 options, because there are 3 options here, so we have 4 upon 1 into 3, that is 12 ways. That is, in fact, we are actually multiplying the number of ways in which event A can happen, event 1 can happen, and event 2 can happen. Their ways are being multiplied. Am I right? Now, why I was emphasizing upon with each one of its way, this will become apparent if I take up one example. This was example 1. Then I'll explain to you example 2. Now, example 2, we take up a portion like, we take up an example like, let's say, we first of all consider numbers, okay? Numbers question, which will involve numbers. So there are many questions in combination which involve numbers. Then there are many questions which involve cards, dices, and so on and so forth, balls, different color balls. So example 2 is based on numbers. First, let us say we have 3, 4, 7, 9, and 2. These 5 digits are there, and we want to make a 5-digit number. Different 5-digit numbers. Different 5-digit numbers. So that becomes very simple. This theorem can be extended to any number of events. That means if you have event A, which can happen in m ways, another event can happen in n ways with each one of its way, and then there is a succession C event which can happen in again p ways. Then in succession there is another event which can happen in q ways. Then together these events can happen in m into n into p into q ways. So I'll add up extends to any number of events. The prime thing is that with each one of its weight should be satisfied. So we consider the first position, the second position, the third position, fourth and fifth. These are the positions of where I need to put in the digits to complete the 5-digit number. So I have 5 options for the first event. These will be considered different events. This is event 1 in which any of the 5 digits can be put. So we have 5 ways in which the first event can be done. When this event is fulfilled within one of its way, the second event can be done in 4 ways. Because you already, with each one of its ways, the one event one way has been blocked here. So rest are 4 digits. Then with one of its way, this can place in 3 ways, this can be done in 2 ways, this can be done in 1 way. So by fundamental theorem, the events can happen in, you need to multiply them, and that will give you 5 factorial, and that is 120. So 120 are the ways in which the 5-digit numbers can be made. So this is very fundamental. Then second, if we consider that only 5-digit even numbers can be made. So by the way, this we have done without repetition. Without repetition. Okay? Without repetition we have done. If with repetition, had the case been with repetition, then we would have done the first event can be done in 5 ways. No, with each one of its way. The other event can also be done in 5 ways because I don't have any restriction. If 7 has been used here, I can again use 7 here. So 5 into 5 into 5 into 5 into 5, that gives me 5 raised to the power 4 ways in case repetition is allowed. Repetition is allowed. I hope you got my understanding, but right now we will be focusing on in which repetition is not allowed. So once again, we come back to 5-digit numbers and which 5-digit number, and we have to make 5-digit even numbers. Now here we are talking about some restriction from the question. So restricted understanding, restricted way of applying this fundamental theorem of multiplication. Here, for a number to be even, I should have 2 or 4, an even digit at the last place. So how many even digits do we have? 4 and 2. So that means rather than starting from 1, taking this as the first event, I consider where the restriction begins. I consider this place can be filled in 2 ways. Am I right? How? Either I can fill 2 or I can fill 4. Any of the digit can be placed here from 2 or 4. Now one of the digits has been placed. So how many digits are left with? 4 digits. So first place 4, then second place 3, then 2, then 1. I hope this descending you understand, because this event can be done in 4 ways, and with one of its way, this event can be done in 3 ways. Why? Because one digit is blocked here, one digit is blocked here. So 3 other digits which are left, which can be put here. So how many even numbers we can form? We can form 4 to the 24 to the 48. 48 ways. 48 ways or 48 numbers. Am I right? Now we include one. Now becomes very important where that important phrase I meant. Suppose along with these 4 digits, 5 digits which I mentioned, 3, 4, 7, 9, 2, I include 0 as well. Okay? Now I include 0 as well. Now once again the question is, first one, different 5-digit numbers have to be made. So first place, second place, third place, fourth place, fifth place. The first place can be filled in. Now, since you have to make a 5-digit number, you are left with only 5 digits which you can use at the first place. Any of the 5 digits can be used. Now, with 1 digit being used here, the second place can be used in. Now, 1 digit has been used out of these 5 digits. Now, one of the digit is added. 1 digit is gone here, 1 digit is added here. So, its second place can again be filled with 5 digits. I hope you understand. Because suppose 3 you have placed here. So, you are left out with 4792, but then 0 is added because at second place 0 can be included. Then this is 4, this is 3, this is 2. I hope this makes it clear. The 525, 4 to 100. 100, 3 is 300, 300, 2 is 600. So 600 ways we can come up with the different numbers without repetition. Mind you, we are doing without repetition. Okay? Now, we come back to one very important point where I consider the second question which I considered was that even number. How many even numbers I can make? 5-digit even numbers without repetition. Now this case has to be considered wherein I'll emphasize upon that with each one of it. So fourth, even numbers we have to make 5 digits, and the digits which are available are these. So we have a restriction at the first place. Why? Because 0 cannot be there. And restriction at the last place where I can use 4, I can use 2, I can use 0. Now you will say, sir, this is not at all difficult, because what we can do is 3 places, out of 4 to 0, the way we did it here, we can fill it in 3 ways. Having filled it in 1 way, the first place can be filled in 5 ways, because 1 way has been used here. But 0 cannot be used, so you either put 5 or 4, I don't know. Then this again 4, because 0 now can be included, then 3, then 2. Now this calculation, whatever we have done, is wrong. Why? Now here comes the most important point. You said that with each one of its way, it can happen in these ways. The rest of the events can happen in these ways. Here the difference is, because suppose you use 4 or 2 here, either 4 or 2 if you place at the 5th position. Then the first place, one of 2 or 4 has gone. Let's say 2 has gone. 0 you cannot place at the first place. So you are left out with 4 digits. So 4 digits, okay. Then again 0 can be included. Then this is right. If 4 or 2 is to be there only at the last position, then this calculation is okay. But here the problem is, suppose 0 is there at the last position, then you are left out with 5 digits. When you are left out with 5 digits, you are able to put, rather than 4, you can put in 5 digits. I hope I make sense to you. And 0 putting means 1 way. So what it means, that since the last place, the first event, 3 ways it is happening. In 3 ways, with each one of its ways, this is not equality. That's why we will not apply either of these methods. So how do we do that? Now, the way we handle it is, number one, I introduce fundamental theorem of addition. Fundamental theorem of addition. Now, fundamental theorem of addition says if an event can happen in n ways, if an event can happen in m ways, or another event can happen in n ways, then either of these events can happen in m plus n ways. That means whenever you have either, or the word English or between the events, connecting between the events, you will always add their number of ways. Whenever between the events you have the word connecting A and D and, then you will be multiplying their ways. That's the simple way. So here, now we do that problem. Having a background of fundamental theorem of addition as well, now we can consider this question. We'll consider two cases. Either 4 or 2 is at the last position, case 1. Either 4 or 2 is at the last position. Case 2, 0 is at the last position. Okay? So when 4 or 2 is at the last position, I'll consider I'll consider the number of ways in a different way. The last place can be filled in 2 ways, either 4 or 2. Then I'm left with either 2 or 4 is gone. So 4 digits and 0 is also there. But for the first place, only 4 digits can be used. Then 0 can be included. So 4, 3 and 2. So number of ways for just changing the 48 to 96 to 102. So 102 ways is for the 48, 96, and case 2, that is either 4 or 2 is at the end space or 0 is at the end space. So 1, 2, 3, 4 or 5. So here 0 alone is occupying the place at the last position. So that is one way in itself. Now we are left with 5, 4, 3, 2. Right? Because 5 digits can be used, 0 is not there. So 5 factorial. 5 factorial means 120. So our number of ways would now become 102 plus 120. Let's make it 222. 222 ways. Am I understood? I hope this gives you a clarity about understanding of fundamental theorem of multiplication and addition and how together they can work out different problems. Thank you.